list what was the problem you were going after, how did your solution achieve that. If you support any industry standards, you get like bonus points. If you put your stuff up on GitHub, you get bonus points. It's not mandatory though. And then the judges will essentially rate you on a score of 1 to 5. 5 is that you exceeded one or more of your brief goals in an innovative way. 4, moderately. 3, you meet one or more. 2, nearly meets at least one brief goal, and 1 point if your team had a pulse. So again, this is less of a startup pitch. You don't need to go too much into like market size and opportunity. I mean, if you want to, you can, but it's not necessary. It's more of just what did you come, what were you trying to accomplish, and how well did you achieve that? Now, also something that is good to know, how many teams in here use ChatGPT to write code for them? Okay, I appreciate your honesty. Okay, how much code did ChatGPT write for you? Okay, cool. All right, well, that doesn't really count. I was talking about someone who was literally like, hey, give me a function for X. Okay, sweet. So no one used AI to build their solutions this weekend. Okay, cool. Thank you for being honest. And then outside of that, yeah, teams should be able to show enough to demonstrate their full vision, how they intend to implement it. And yeah, and then our judges is this, do we have a slide that shows our, these are very tough judges. They're ready to put some blood in the water. Shh, I'm trying to build y'all up, be quiet. If you're too soft, come on, that's no fun. And so do we have a slide of judges? Maybe not. Well, I guess very quickly if the judges want to. Oh, here we go. All right, super. So each team will have roughly around 10 minutes to present. When you hear the alarm go off on my phone, that means that you have 1 minute left, right? So just try to wrap it up. The only people who will be allowed to ask questions are the judges, but after a team presents and later on while the judges are judging, you're more than welcome to ask questions to the teams. Any questions that we have about what's about to happen? Comments, concerns? No. Dope. All right. Well, of course, let's see, we covered everything. All right. So I hope everyone had fun this weekend. Yeah, did something cool, met some people. All right, sweet. All right, so first up, we're gonna have Piletastic 4, and then the Snitchers are on deck. So Piletastic 4. And then to run your presentation, you have either the HDMI here or the USB-C. So which do you prefer, sir? HDMI or wrong side? Super. All right. Excuse me.
Hello. Hi, everyone. So we are Piletastic 4. So our team has Hiroshi, Konstantin, Yami is sick, so he's, I think, hopefully online, and myself, Sanjay. So, what is the problem? So we had this project with our company. We supposed to design a lot of Pile slabs, and we tried to do it with some optimizations from Grasshopper, but there was always this problem that we do something, we send it to the site, and then site is like, no, we have some issues, and you need to move piles. And like, okay, it comes back to the office, and then we do the calculation, and then the issue is that, or our pain is that Design changes every time. It is our job to supplement every design option with the best solution, which is optimized. So we had this optimization problem, and we came here with this problem, and we seeked out some teammates to help us to find a solution which helps us save time and resources. Next, please. So we have this 4-step program. Konstantin will go through the steps, and then we'll talk about those.
Yeah, I'll start with step one we have. So the idea, or the whole idea, is that actually to use the machine learning algorithms to come up with the optimized solution for us. But the first step is actually where to get a training data set. And one of the options is actually to generate a small training data set, so they can actually afterwards use machine learning to run more iterations. And I can, depending on the complexity of the model, it can, the big model can run long time, the small model can run faster, but in principle you can use your FEM software, the one which you use, to actually build a training data set for you. So you will have a correct data there. And this is what we tried to do. We used we automatized, sorry. yes. We automatized the run process, basically. So in our case, we have set up scripts which creates the model in text file, which can be afterwards used by FEM software, runs it, records the result, and stores them in a CSV file. And this is basically how it's built. So we started with our trial example was a pile slab 5 by 5 meters with 15 piles on 15 piles. And we are running, you can see, with a random position of the piles. And then we record the training data set. And Hiroshi will proceed and take over for now and tell how we wanted to attempt at least the machine learning part.
So first, how it should be solved, then if you can have the opportunity to try infinite number of the combination of parameters, then you can eventually find the optimal parameters. But the problem is that simulator is too slow, so we cannot try everything. And then we come up with the idea of the lightweight simulator as a deep neural network. But to solve the problem, we still when we started, we didn't have a data set yet from the FEM simulators, and so I need to prepare for the more simplified version of the environment. So then we come up with the Voronoi regions. So this is each point has a equivalent distance against the other points. So the circled area can be considered as a weight. So this is a very simplified version of the pile slab case. And we started here, and also there is another problem. The neural network has a fixed structure, so the input size is always fixed number, but pile numbers gonna be the variable. And to solve that, there is again, this is the supervised learning. So there is a input and output to the data set, and we train based on that. But again, coming back to the various number of the pile, we need to deal with the another architecture, graph neural network. With that graph neural network, we can provide the variable number of the piles, and then we supposed to get the lightweight version of the behavior simulator. So the FEM simulator is exactly it's simulating physics, but with neural network, with graph neural network, we get a behavior simulator. So input and output is quite similar, but internally it's just so lightweight. And with that, we could try the quite many trials. And after that, we supposed to try the same cross entropy method or some back propagation to find out the moving the original input. But I still have not make it work yet. So it's gonna be a remaining task for me.
Okay. So then we move to step 3, where we supposed to validate the train data, but since we didn't have time, and as Hiroshi mentioned, it was quite some task to get it working. But if we had this thing working, so we had planned to have like one random plot size. We put it in the machine, and then it gives us the optimized location of the piles for that plot size. And then we would run that option with our FEM software just to validate if whatever is generated is correct or not. So how do we take this application in our regular life? So the scenario would be that you have a piece of land which comes up from the client or contractor or someone. So then you put out the geometry in the machine with minimum number of piles and the deviation you would like for each pile to have. And then the output should be ideal case scenario, that perfect optimized solution for the pile slab. And as an engineer, you don't have to go too much with number of iterations, but just check the option which you have is like working as a good structure output. That was our team or our problem and the proposed solution for today. We would like to thank Alexander. I don't know if he's here today, but he helped us yesterday with a lot of machine learning stuff. And thank you. We will save the Python scripts at some point at GitHub, maybe today or tomorrow. But thank you.
Nice work. Questions from the judges?
Thanks for the presentation. Very interesting application. You mentioned when you started the presentation that you save time, but who will save time actually?
So the case scenario is that a design office, where let's say where I come from, has to check multiple iterations of possible pile locations. So sometimes the iterations go like 15 times, 20 times. But like I mentioned in the first slide, that the project was like this big. So we had like 200 to 250 slabs. So imagine like 200 multiplied by 10. So 2000 times I'm sitting on computer making a choice. But then every pile or every slab has like 20 load cases, soil weight, tram going on top, cars running, snow, and every load has multiple load combinations. So it's an iterative process and it goes on and on and on. So basically I save the time to design if I don't do so much iterations, and I have maybe like 3 best solutions for each slab and just look at them and go ahead from there.
Is this something that design engineer like you would do? How often? How often do you face projects like this?
Basically, every project has to have piles, at least most of them, and it can be this basically is a tram slab. It could be building cases. It could be tunnels, bridges. So depends on the soil type, but you always have these kind of cases coming up where you need to have the best case scenario for piles.
Hello, thanks for the presentation. I have a question about, it seems that you have thought about the problem and the solution to the problem for a longer time. How much do you actually develop the solution this weekend? How much did you do earlier?
All this is done this weekend. The problem was when this project came to us, but we tried to not do this machine learning and this part because, well, I and my team is not equipped with it. We had a different solution, but it didn't work. But we kept the problem in our pocket, and then Yami and I, when we came here, we kind of sketched it out on the whiteboard and tried to speak with people who had the skill set to help us out. And that's where we found Hiroshi and Konstantin to help us out.
Thank you.
Thank you also from my behalf. impressive work. I had pretty much the same question as Arni. So who is the customer? What is the problem size? But you already answered those. So my question now is that, is this something that you could take into use immediately in your work?
Yes. Well, the data training took a lot of time and head scratching, but if we have some guys who help us out with those, like Hiroshi, so yeah, I'm not sure how much time it takes to get it working. Let's say 2 weeks. Then, if we have some training data sets, yes, we can start working. So my ideal life would look like that. Before I go home from work, I can put that thing on the iterative model, let it run overnight, have training data sets next morning, put in the machine learning stuff, and then get output from there.
Okay.
Could be
Ready
like,
to use.
yeah, thank you.
Maybe my final question is about the output of this process. I think you mentioned that it will be like a tabular data, or what is the application that will use this positional data as starting point?
It could be like a FEM software. So let me show you this one. Sure.
I mean, what you get as an output, I mean, you end up with a pile layout, which a contractor, which a designer can finalize the design upon, and the contractor can build afterwards. And you're not, and in principle, you can also save the amount of piles if the layout is good.
Okay. Yeah. Do we have any other questions? Okay. Thank you very much for your.
So much, team. Job well done. Super, super. All right. And then up next, we are going to have team the Snitchers. Okay, so real quick, I was told, because we know people in the stream want to see your beautiful faces, make sure that as a presenter, you can see yourself down here on the screen that's down on the bottom here. And yeah, that way people online can see. Test, okay. Did I take the wrong microphone? Now it's on. Okay, cool. All right.
Already project.
Oh, you have to use that?
I took that away.
Yeah.
There's no HDMI. Oh, yeah. I can get it through here. Maybe.
Yeah, there you go. Underport. All right. And Bid Buddies is on deck.
Snitchers.
Well, on deck. Snitchers is presenting now, but on deck is Bid Buddies. Oh, that's okay. That's okay. I shouldn't have. Should auto detect. So for the next hackathon, it's going to be hack PowerPoint. And here we go. Something's happening. Oh my God, your desktop. Oh, oh, oh. I'm not going to OCD. No OCD. No OCD. Okay. I didn't see that. All right. Go team.
All right. Thanks for joining. We are the Snitchers. And straight to the problem. So we all know that we need to reduce the CO emissions of the construction industry heavily in the upcoming decades. And but as professionals, we often end up with smaller problems. So what we have problems in the construction sites and in the design companies that we face lots of time and budget constraints in our design. there's a lot of silent knowledge in the industry, but we are not able to many times spread the knowledge between the professionals. Junior designers might get left out of the loop, especially now with the hybrid workflows and people work from home. So that might end up with lack of optimization in our design. And also the CO2 altogether. So we are structural engineers and we design structures. So we used to design them so the buildings can stand up, but now we also need to think about how much CO2 emissions there is. So that's a little bit of a new task for us. And that might end up in something like this. So many times in our designs, we end up with low utilization structures. What does that mean? It means that we make too big structures that is actually needed. We put too much reinforcement into our columns and beams, and it's not really needed in there. But no one actually knows that. It's just there. We put concrete in. We have a nice building in here. It stands up, but no one really can tell that is it an optimized building or not. So overuse of materials is a big problem, and unnecessary CO2 emissions. And that also leads to increased costs and reduced efficiency of the buildings. So,
ladies and gentlemen, we are very happy to introduce the new Snitch, the green designer's best friend. So, what does Snitch do? Snitch will tell you where the poop is in your design. Okay. So, what's the objective of Snitch? So, the idea is to get a tool to quickly verify the quality of the design and whether it's optimized or not. So, it should be a 5 to 10 minutes job, nothing more, because as we said, we have big time constraints. In the detail design phase, because we already have some tools that allow us to select the best, which way is it? No, yeah, the best constructive system during the general design phase, but during the detail design phase, we don't have that yet. Next. And then the idea is to quickly visualize and have a feedback in the 3D model of where the members are optimized and where the members are not optimized. And it's nice if it looks good. So we are trying to implement amazing color gradients. And the idea is that at the same time, since we are checking whether it's optimized or not, we can also get the CO2 emissions calculated directly from the same tool. And hopefully we will save CO2 emissions by having a building that is fully optimized. So for who is that? The first people is us. So design companies, structural designers, so that we can evaluate our own work. But it can also be applied to investors, such as construction companies, developers, to check whether we did a good job or not. So that's why Snitch is here. So cities and construction designers. So for this weekend, the use case that we decided to go for is a concrete frame building, so quite a simple structure. And we decided to focus on only the slabs and the columns, and for simplicity purpose, query the model directly from a Tekla model rather than any other type of BIM model, because we can tap directly into the 3D database. And we've decided to get only 3 buildings, optimized building as a use case or as an example to train our data. To then be able to show you in the future that whether the building is optimized or not. And yeah, as I mentioned, we are doing that on slabs and columns only. And in the future, we're going to try to expand on that. So the solution, we said already, is Snitch. So now we're going to present to you how Snitch works.
Yeah. So how is this all done? So first, what we need to do is we need to establish a good database of projects. And that can be done by senior designs that know what structure are optimized and what not. So we are ready to start. We start with the BIM model. And then we out of the BIM model, we create a snitch model. So what we actually do, we grab the BIM model and modify it, extract the metadata out of that, and store it in the database. And then after that, when we have extracted some of the metadata, we do analyze. We analyze the metadata. So we add loading areas, floors, and forces for each structural member. And then we have the good project database, and now we are actually able to compare the newly designed building against, let's say, similar kind of buildings that are stored already in the database. And now where the snitch actually comes is it identifies if there's a poop in the design. And if it's not a good design, we iterate the design process. And when we have, let's say, iterated the process multiple times, we are fine with the design, we get a good boy certificate. And now the design is well done, so we can actually push the good design back to the database. And then on top of this, we can actually try to implement the AI that would learn and maybe suggest the optimum solutions for next projects. And now something about the back end side of how this everything works.
Yes, we decided to go with C# since it's familiar for all of us, and we created KIRAHub components, which creates that snitch model, and then in these components, they create those snitch slabs, columns, and beams, and then there is some logic to calculate CO2 values and then analyze the model. And this is the front end. It's in the Grasshopper, but in future it would be like perhaps a web tool or separated desktop tool. But for this use case, it was easy to use just Grasshopper. And what future works do we have for this project is create a big database of good solutions and add multiple different types of buildings and elements, and then utilize AI. But in this project, we already utilized AI a bit since the logo is made by DALL-E AI. And then we have the GitHub is public. You can go there. It's Snitcher, and then the logo is also public. So go to the link.
So, but now the real question is, does it work? So we're going to do a live demo. We are taking a lot of risk here, so bear with us. The idea is that we have, I think you need to share your screen. But essentially, we have a Tekla model that is up and running, and we can show you what the snitcher is gonna show us. So here you have the Tekla model that is at the moment fairly optimized. So this is like a concrete beam, well, columns and slabs. And let's imagine that somebody is a bad designer, so he's going to change the size of a column, make it very, very big. Or change the reinforcement. You're in the component selection. Okay, so now it's a very big beam column. Sorry about that. So now we go back to our interface. We just refresh. And we have our user interface as well. That is somewhere. That's the demo effect. There's always a demo effect. Okay, it's loading. There's a lot of stuff to analyze, so Snitch is working really, really hard for us. Okay, so here it is. Now you have your report. It tells you that, for instance, for your whole building, You can either select the whole building or your structural elements. So now we know that the columns are 11% of the global CO2 emissions of the building, 56.88 tons, and that we have 270 columns that are good, one that is so-so, two that are not so good, and one that is very, very bad. And we can see that it's there. It's the one we changed. And then we can also, if we want, have a look at the slabs. And we're going to have the same nice visual data, and we can realize that one slab is actually, we have two slabs that are bad, and that the slabs are playing for 89% of the CO2 emission of the building. So definitely you got to optimize your slabs. And we can do that at the moment for both the concrete volume and the reinforcement within each structural element. So yeah.
I think that's it.
Well, that's it. We had one last slide to tell a bit who we are. So there is two bridge designers, Juha and I, and then Matti, Poja, and Jukka are structural designers, and we are coming from two different companies, and had a lot of fun doing this this weekend. So thank you for your attention.
Super. Great job. All right, questions from the judges.
Thank you. I especially like the live demo. That's always exciting and looks good. Coming from the commercial side, so to say, I really like the definition of the good design and good boy certificate. So did you have any time to think how to define the good? Is it 10% savings, 30%, or is it like, adaptable case by case?
Well, we have in the database the good design. So I would say that as a structural engineer, I would say that if you get to within 10% of the good design, you should get already a good boy certificate, because the working life is many times with the time constraints and everything quite hard. So you cannot ever get to the optimal, but if you can get within 10% of the optimal, you're really good already.
Okay, and the savings apply to the same,
Well, of course, there are those designs that are already saved, so we don't really aim for savings, but we aim for optimal design.
Sorry, I just took it from your hand. Structural engineers are super important, but I know people who would hate you, but because of this idea. For example, unfortunately deceased Zaha Hadid used an interesting structure, and you had to put a lot of steel in it to make it up. And so it doesn't mean that these designs shouldn't be CO2 friendly, or they shouldn't think about it. Therefore, your solution actually comes into a point that it should be applied to every single design that architects do. And therefore, I like the challenge that you took, because there's a lot of things to do. But it's also like, I would like to ask you a kind of an abstract question, which is like, what is good to you?
Well, we were actually discussing this a lot with that, especially with the architecture. You can have that will increase the quality of life decisions, but will cost more CO2. But with the structural engineering, it's a lot more defined, actually, that most of our buildings that we build in Finland, for example, are housing multi-story buildings, and they're pretty close to each other. So we can actually aim towards optimal solution in those. So I don't think this tool is for design for these architectural nice, really important structures, but this is for the general structures that we have 1,000, 10,000 buildings in Finland, and we are trying to get the database out of those, and those are easy to compare to each other. So I think for architecture, it's hard to define what is good and bad, but for our structural engineers, it's easier when we're going with the normal structures. Let's put it that way.
Thank you.
Okay, yeah, very, very impressive demo. My question is, why would we need a tool like this? Shouldn't you, as professionals, already know what is good?
Hard hit. I think that's why we started with the first slide, that there is a lot of time constraints, and then there are lots of different kind of professionals in the field, unfortunately. So a structural engineer is not a structural engineer. There are good and bad structural engineers. So it's unfortunately, we get good and bad designs, and it's hard to evaluate them when you are, let's say, a client and you get a design. You cannot really tell, is that column optimized column or not? Even I cannot tell, is that column optimized column or not? So we need the tool also to spot the poop.
Not to mention that actually this is a new design task for us to optimize for CO2 emissions. So from a designer that has 20 years of experience, he actually has to learn a new aspect of his work, which is how to optimize the structure for CO2 emissions, which might not be the optimal answer from a structural point of view. So sometimes the objectives are antagonist, and this is a whole field of our work that we have to deal with now that we didn't have to deal 10 years ago.
Okay, thanks.
Yeah, just one more question about the adaptation of this technique. So is it ready to use? Would you take it into use tomorrow?
Not tomorrow. So this is a proof of concept, of course, and it actually works. So it did calculate the real CO2 data, and it had a database where it did the comparison. But of course, we would need a lot more buildings to get a better results. And the technology is there, but the implementation still needs the real product.
Then the last question, I think, is, are you for one company, or are you willing to share your solution to all the others as well?
This is freely available in the GitHub, and we are from 2 companies in our team, so
Perfect.
anyone can grab it.
Yeah, that's wonderful. Okay, thank you.
You mentioned Tekla as a commercial product. How about open standard like IFC files?
Yeah, we forgot to mention that in the presentation, but the idea is that it would be the main use case would be with IFC. We used only Tekla in this because that we got the proof of concept done fast.
Thank you so much, team. Job well done. All right, so up next we have Bid Buddies, and then on deck after Bid Buddies is B4B Market. Good building industry fashion. We're a little bit behind schedule, but that doesn't matter. So no way, man, we're under budget. So whenever you're ready,
Yeah.
floor is yours.
Good. Hello to you all. Happy to be here today. And we are bid buddies, and we are doing the winning bid. So we have a problem in our industry. Projects are becoming more complex and diverse. Identifying experts in multidisciplinary projects and the skills needed in them is becoming increasingly challenging. And also the demands of tenders are increasing at the same time as there is a shortage of experts in the field. So the use of diverse expertise in projects brings a new perspective to the projects and increases the competence in a field. At the same time, the inclusion of young talent to the field must be supported. So we have the problem that the best experts are troubled by time and lack of resources. more efficient tendering work eases the workload of experts, increases job satisfaction, and shifts time of the best resource, not only to the project we do, but also training young people and developing to the field. So that's why we want to automation of tender work. So technical solutions. Thank you.
Yep. So, okay. Yep. So how we started is that we crawl through our SharePoint and network drives that we have to fetch the tenders and tender requests that we have. We got the crawl working and we insert them to Azure Blob Storage, could be any data lake or anything. And then we built a ML model with form recognizer in Azure to actually go through those PDF files and find important keywords, well, such as the organization who requests it and the cost of the tender, of course, and also some industry-specific words. What is it about construction or environment or CO2 emissions or similar things like that. We use Databricks to actually use this model that we built to go through a whole lot of these PDF files and get this data formatted to storage account in a machine readable format, basically table format. After that, the idea is to be able to compare tender requests by these keywords and see which tenders we actually win and how do we achieve that. The idea is to have an algorithm based on weighted keywords and issues there, but we didn't get that far. The ideas for this future development was that we would also include people's CVs. It could go through the same data pipeline that we already have. And with this, we could add those same keywords that we already get in tender requests and combine them with people's CVs. So we get the dream team that we want. Similar to project references, again, we can multiply and scale this data pipeline that we already have. And also for resourcing. One idea was that we could also use this to train an AI in talent search. So we were thinking about this open AI that Microsoft is launching now, that we could use this. And as discussed, the next thing definitely would be the algorithm for suggesting these model tenders based on these weighted similarities. Then we did also get Figma model for how we would actually use this in professional life.
Yes, we did. So I'm going to show you what it could maybe look like. If we can. Here we go. And the last one, thank you for waiting. So here we are. So we have this, we call it a bid box. So you first upload your request for offer here, and then our solution goes through it. You can see it here. We uploaded planning for the future of construction industry, and our solution gave us the keywords that it could find. And we can pick and choose which one we like and which one we don't like. And we can manually also add some keywords that we would like to have when it goes through the previous offers. And then when we are happy with the keywords, we search for the previous offers that we have won, and that has the best matches, and we can see basic information of them. And here we got the team that below here, we got the team that worked on the project. So we can check who are the ones that know about this and who could we use on the next project and make the offer. And then when we are happy with this, we have checked all the information we needed, we continue and we get the preliminary offer for the bid, for the request for offer. And here we have some amazing information on here. So we get project description, methodology, deliverables, price, schedule, and the dream team that we can offer for the project. And here we go. Thank you. Anything to add? No. We're good. Thank you.
Thank you for the presentation. I think you are tackling something that is very profoundly wrong in our society, which is procurement law, which is fortunately will be renewed. Hopefully next government once is coming. But I was asking about the, did you think about the methodology that once there is a problem in tender, that you have, do you kind of scrum it up and then offer a method that is unique somehow? Because that's kind of the beef of the tender usually, or what you give as a solution.
Well, this is kind of at the first. This is for the bids which are kind of similar, and we can use the same descriptions, but we can add it also our methodology there. So we don't just print it. Yeah.
Yeah, I assume that there's a lot of like manual work afterwards that you have to kind of deal with it. But it's interesting start to think about, like, because it's a very bulky work what you try to manage here.
Yes, thank you. As a person who has dealt with tenders and answered some, this is amazing. Yeah, I was still thinking about the from the buyer's point of view, like, how does this answer to their needs? So they probably want a unique solution for each of their tenders. So
yeah, sure. We just do the work we can do with this, and then use our own methodology to do the work. So we cannot automatize it all, actually.
Sorry, I'm going to continue on that one. What are your next steps on working with it? Like, how would you develop it even further to make it such a way that it's unique offer to the tender? Like, for example, using generative AI or something else?
Yep. So the key point here for future development was that we would add or do the same for our employee CVs. So we could actually personalize the team, especially for that tender, based on their requests. Because in a larger company, it can be very hard to actually find people who are good at this, or then you just always go with the one person. So we have one guy doing hundreds of projects because that's who we know, right? So this one would actually ease the load throughout the company. So we get more people on the projects, as well as we can include juniors with this.
Okay. I think one of the key issues whenever you start using or writing bids is the availability of resources at the specific time frame. So that, I think, will be the decisive factor, because you can, of course, propose that we will use these experts, but are they available? What is that? Do you have any ideas how to solve that? Do you already have systems that would help in that to integrate with those systems?
Well, yes, that is data that we already have in like our resourcing system, so we can get that.
Yeah.
Like we can know what kind of projects our employees work on and how much is their resourcing situation.
Okay. Yeah.
But that would be a good point actually, that we would need to add it here, because otherwise we will just get the dream team, and obviously there will always be.
Yes. All right.
Yeah, I could ask about the openness, because this was done, of course, on your company data and your company information. So are you ready to give the code out?
I could give the code out for the transformations. So that was actually, we used public tender data to train our model. So it's like
Yeah,
no
because
issue.
because there's a lot of public data on different tenders available, so it would be easy to do that. Thank you.
Any other questions? No. Thank you very much, team. Nice work. Nice work. So up next we have B4B Market and on deck team NCCA. Yeah, they're going to do like an interview format.
This thing on?
Yeah, exactly. Maybe, yeah.
Make sure you can see myself.
Sort of here, so
Nice shirt. Yes.
and
Roy, just make sure you can see yourself.
yeah, exactly.
So you go a little bit to your left.
Go over there. Go over there.
Perfect. Perfect.
Don't be shy.
It's for the people on the other end.
We're ready. Now on to something quite different. I think we're ready. Hit it. All right. Good afternoon from our part as well. So we are B4B Market, building for building markets. I'll introduce the team at the end, actually. But first, before we go very far, actually, can you move the chair a bit? We can't see the text. So, as said, building for building market and really construction industry, construction waste and reuse, recycling that into new buildings. Now, before we go very far, first a little game, if you wish. How many bricks? Can I have some shout outs from the audience? 10,000, thank you. How many?
We got 20,000 ones.
More? 7,000, thank you. 2,193 bricks. Leo, can you actually talk about a little bit, how do we arrive at this number?
Yeah, exactly. Yeah, totally. So we segmented the photo using AI to get into this point. Then we had a small Python script that actually, to scale, evaluates approximately how many bricks there are in this building. And it's not only for photos. If you can take the next slide, please. It actually also works for drawings. So we've gone on left, we've got a drawing of a building, and you can see this one doesn't have the windows, doesn't have kind of like the balconies and so forth. So it was also able to evaluate that one.
So this is relevant. At first, we're talking about bricks in terms of the construction waste. So the big problem, which we're now coming to, has to do with the waste on construction sites. So first of all, Shiva, can you talk about a bit of the waste coming out of a construction ecosystem?
Yeah, I want to tell you that 33% of the total waste is for construction industry. as well as 35% of waste disposed in landfills is for construction and demolition of a building. Also, you know that 30% of the CO2 emission in the world is for construction industry, except, for example, the residential part of the building.
Yeah. So now to go into sort of more detail about bricks and the waste from them. So there's a further point about if you can continue with that about the reuse and brand new bricks.
Yeah, for example, when we produce 1 ton of new brick, it produces 230 kilogram of CO2. And when we reuse or recycle brick, it only releases 16 kilogram per ton. So here we will save 92% of CO2 emission in the world. Yeah.
When we reuse some of the building materials, and in this case, bricks. So the idea of what we're talking about here is reusing, taking bricks from demolished buildings and passing them onwards to be reused in another new to be built building. And so we have two kinds of sort of stakeholders, if you will. Leo, if you want to talk about that.
Yeah. So people with existing buildings that are about to be demolished, that have brick facades. The bricks are actually a cost for them because they have to pay for getting rid of this waste. At the same time, there are people who want to buy old bricks, and it is difficult for them to find old bricks.
Yeah.
There are also other things, but let's not go into depth on those.
Exactly. Yeah. In the interest of time. So we are going to be in the middle of that. So the solution that we're talking about here is in a not very complicated way. Do we actually get to the website here? Well, we're
We've got a website that's actually online. If you go to the URL, you can actually find it.
Exactly. So quite simply, what we're talking about is providing a platform through which you can act as a middleman, middle woman, if you want, between these two actors. So the people who want to get rid of bricks from their demolishing sites and the ones who are building new buildings with a brick facade. And so bricks is what we were talking about at first. Later on, there is scope for other materials, but the bricks is actually a very good case for to start with for various reasons. So, oops. So as you can see here, there are different kinds of bricks. I mean, they have a different appearance, and there are different prices for bricks. And the idea here is that people who are interested in buying bricks to build beautiful buildings might have a preference for different colors. So, but further on, for maybe Leo, if you want to continue about why we're actually starting from bricks. Why are bricks so suitable for this business?
Because this is like in the long term, you wanna really kind of like do this for all kinds of different construction materials. But why start from bricks? Well, I mean, bricks are used all over the world, obviously, and there is already an existing market for reusing bricks. It is an inefficient market though, and this is something that can optimize that. As we showed before, every reused brick actually saves CO2 as well. And, well, bricks are modular. They are standardized. So a brick you take from one house, you can actually use it in another house very easily. Much easier than other building components. And the best part is actually that bricks increase in value over time. It's an aesthetic thing. So old bricks are actually valued higher than new bricks. There is even kind of like this exponentiality to it at the very end. Kind of like some really rare old bricks can be very, very valuable. But, you know, the ones you would use for construction are slightly different. They're just a little bit more expensive.
So here we've listed a bunch of benefits from this platform, from this sort of service that we would provide. And it's supposed to be an easy to use marketplace between these two actors. And part of it, what we've actually haven't talked about yet is a certification function whereby you make sure that the bricks that you're taking from a demolished building actually work in a new building. So there are chemical properties of bricks having to do with things like acidity of the clay having been used. That is a relevant piece of information for anybody wanting to use those bricks. And into the platform, we would bring also data from other public data sources about when was a building built, which would then give indication of what the brick composition, the chemical composition of the brick, what that would entail, whether it actually is at the end of its life cycle or whether it can be used. Anyway, moving onwards, we have a little bit here left about the sort of life cycle of construction industry or buildings. Do you want to, Shiva, maybe talk about that a bit?
Yeah, currently, as you know, we have a kind of linear process for our building. We put virgin material to our building, but we are not aware about the waste of the construction. So our main concept is to reuse the building's components. We start from brick because of the benefit. Leo already talked about it. So we start from brick, but our concept is kind of reusing buildings component as much as we can. So in next slide, if you show, we would like to reuse 50 to 100% of the building's component, and this could help us to the circular architecture, I think. Yeah.
Exactly. So the linear model moves into this one where at the end it's actually a circular recycling the materials. And we're at the end of our wonderful presentation, if I say so myself. So my name is Roy. This is Leo, Shiva, Ali, and Blagoy. And so we've done all a lot of work on this. So Leo, for example, was responsible for a lot of the AI stuff in the beginning about the bricks and a lot of the planning. And Shiva,
it's a timer.
Shiva actually was the engine at the beginning of the whole ideas and working a lot on the slides, but also developing the ideas very much. Ali developed the website very much and was the sort of the technical developer of this presentation and the website. And then Blagoy did a lot of the research. He had the responsibility for the research. And
and then we also got Roy, of course, who's been a mentor, a project manager, and a great deal of guidance as well for the team. And well, I mean, it's also been great being here with kind of like talking to the judges, to all the wonderful people here. Thank you all.
And I wanted to point out in this wonderful picture, we have Aske, who was actually great help to us in terms of talking about the bricks, understanding the chemical aspect of the bricks and the verification. This is us. I think we're finished, and welcome to take questions from the judges. Maybe I'll pass this on.
Thank you.
Thank you for the presentation. I like the idea because this definitely needs thinking and lots of effort. And I also like that you started with one thing, which is a brick, which is very originally, once it's done, it's very energy consuming and CO2 producing material. But also, while we have a lot of buildings, I have actually two questions, but I'm starting with one. Once it's dismantled, like it might have problems within, like something to problems, like for example, regarding health or something like that. So what do you think? Do you have any idea, or do you take any kind of comment on that? That how do you pre-handle the bricks to make it safe, so it's kind of a CE certified or certified as a safe product, as a comparable to the virgin material brick? Did you take that? Any comments on that one?
Yeah. Hold on, I'm thinking. If it's okay if one of you answer the question.
Well, on the safety and certification, that's actually what prevents currently from reusing building material mostly, because that's kind of frightening to use a material that's, makes you liable at the end. The thing that we're doing first about the starting bricks, we can start from, facade bricks that are, much lower requirements of qualification. But in general, for other types of bricks or other kind of construction components, we plan to provide with assessment and certification. And these are different types of certifications, those that we can provide or those that we need to outsource. But in general, it's normally not that hard to reassess that material, and I mean not that expensive to reassess and recertify it that this is structurally integral and can hold on.
If I just quickly may add to that, the idea here is that there is a, for example, issue of liability in the middle. So when somebody wants to sell bricks and another one wants to buy, but there's this issue of potential risk and the liability of who guarantees that they're actually still safe and sound. So we take on that as a service, and we, whether it's us or we certify it with an outside expert authority on that they actually are, then we do whatever treatment is needed, or some may be discarded if they're not valid anymore.
Okay, thanks. Yeah, this is a good, I think a really good idea to, but one thing that I know about recycling and reuse of materials is timing. So whenever you have some bricks, is it the moment that somebody will need it, or vice versa?
Yes, this is a very good question. So, yeah, well, once you've decided that a building is going to be demolished, there is essentially a timer. Yeah, well, you can think of this as kind of like a negative thing, but however, we're trying to sell bricks, and this timer is something that forces the owner of the building to get rid of them. They have a timer, they need to sell them quickly, so that kind of like that pushes the price down. And on the buyer side, there is also a timer. It's kind of like an ale in a store, right? There's a timer. You got to buy them fast. It actually might work in the favor of the business.
Okay.
Does that answer your question?
Yeah. I have a suggestion for your company's or service name. It's Tinder for bricks.
Nice. You heard it here first.
Thank you for the presentation. Of course, the city of Helsinki has the circular economy cluster for construction, and all these kind of solutions are very interesting also for the city we are currently in now. But this is not a first. What makes you different from the previous marketplaces or existing marketplaces?
Yeah. Do you want to take it? Okay. Yep.
Well, it depends on what scale you're looking at our work. About the brick, if we want to, plan on reselling only the brick, we're not that much higher of the existing markets. But the point that we do is that the bricks are just an initial offer to get attraction, and we can actually go for that without profit or even with loss. That's what gets us advanced in this scale. And in the bigger scale, the marketplace, running a marketplace is always difficult because you have to bring the other side, right? It's every kind of double-sided business. So I think the biggest strategy that we have that can makes us different is a break strategy, that we first identify buildings that are going to be demolished with a lot of bricks in them, and go with an offer to the seller. And that offer can be something really, tempting, because we can reduce or we can actually spend on the construction costs of that building for them in return to a time and the permission to sell all the material. So we can have a big market, a big variety of reusable construction material without having a lot of loss, which makes the market for us. As I know, there's no really big market already that allows you to really design based on what's available. And in the end, we have a variety of different components ported into the software. There was this platform, ProdLeap, that is being used for new material. You can use the same platform. And this is actually something that we didn't find. So I think that this is basically the strategy that we are tackling it.
I have a last question, I think. Well, comment first. You might be first ones to solve this problem, that if your idea is basically to be the first one to map out those buildings that will be demolished, you're making it right and by the law, you are the first ones to do that, because it's the private ownership that the building owners have for the bricks, and they are owning the stuff. And once it's demolished, it belongs to the company that demolished it, and then to the company that takes it to the landfill, basically. So the legislative system is not really following the need, what you're suggesting. So basically, if you prove that point that there is a need for market to a kind of a middleman, so somebody else could own it, the material in between, you would solve a bigger problem. But while it's probably not possible, but in legal framework. But also, I didn't really get can anybody basically add information? Like, I have a pile of bricks in my yard, come and take it out. Can I do that in your solution?
Yeah, so we will of course kind of discuss this at length, but this is something that's going to change at the early phase of the company, then at the middle phase, and at the late stage. At the first stage, it has to be quite unscalable. Talking to the people who actually own the buildings. That's not going to scale later on. At some point, it's going to have to change to a point where the owner of the material enters it into the system. Yep. Does that answer your question?
Well, yeah, basically.
Yeah. All right. Any more questions? Thank you.
Super. Awesome. Thank you very much. Super awesome. So up next, we have Team NCCA. And then last up, Creatimus and Wix for... That looks right. Always impressive to see what people can do in under 48 hours. Yeah. For sure. All right.
Yeah.
Oh, you've got your own timer. All right. I like that. So just let me know when you're ready. Good. Ready? All right. We have our next presentation. If the judges are ready, the audience is ready, and let's get started. The floor is yours.
All right. Hello, judges. Hello, everybody. Hi, Mom. Me and my team NCCA, had 4 people. Unfortunately, 3 of us couldn't make it here today for various reasons. Me, Veikko, I'm a data analyst at NCC, and Riku also works as the VDC manager at NCC, and then Olli is a mystery hero for our team. From Jyväskylä, I also had to leave, and Jussi as well from engineers, Insinöörit group. And we probably had something a little bit different than other people did. We had a very regular Monday to Friday problem at our offices. And as many of you probably know, the level of digitalization in the construction industries is not the best. I believe it was McKinsey and Company in like 6 years ago listed 20 different industries, and construction was there on third last, only above hunting and agriculture. So the issue at the office that we had was in construction projects, the BIM designers write weekly reports about the progress and status of the models they have been creating, and as you can see here, it's just a PDF document with the dates and some written information, and then it's quite cumbersome, and it's very hard to follow up and report on that. And if the manager wants to see, okay, what has happened in the past, has to read through 5 pages of this, and then if there are 5 different model disciplines from architecture and structural models, and then you have 2 different versions from those, it's gets quite difficult to see what has been happening. And so what we did, we just sent this to ChatGPT, and that did all the thing right. And no, that's not actually like how easily we can do it at the office. Like technically, probably yes, in the future, sure. Just let someone AI read this, and that's it. But for us, it's the solution was a little bit more common and casual. Just create an app where you can input that data and show a Power BI report from that afterwards. And what we wanted to have as the use cases for this, our solution was the user stories was to describe the designers want to describe the changes that they make to the models. They want to input those into like an interface, and then design managers and BIM coordinators want to see a report from those, whatever it is, Power BI, Tableau, whatever you have, and to have like quick inspection and status checks and stuff like that. Okay, and what we used for this was Microsoft Power Apps and Microsoft Power BI, simply because that's just most often the environment you have at the office, which is also the case at NCC. And also in the future, when Microsoft launches Copilot for the wider audience, you can do the apps with just describing to the Copilot what you want to have in the application, and that's going to be fun for me at least. So additionally, we wanted to connect the data into our IFC models, and so you could visualize the 3D model next to the status reports. So we pulled some data from an actual IFC model we had, and I then used Tracer, which is an external plugin tool for Power BI to visualize the IFC model there. And here's what kind of data we had there. So you have different model versions. Each version has buildings, each building has floors, each floor has space groups, and each space group has names. That's what we use here, but of course you could go further here to the object types and the objects, and straight into like the last screws you even have if you just have the data underlying there. And this is the boring looking user interface with Power Apps. We created a small database and then pull that data to the Power App. And yeah, reminder, we are not UX designers. And then so you put a comment there, and you can decide if you could put the comment into for the floor level or the space level or the space group or the building. And also has that space been the design of the space being started or not started, or is it on hold or whatever. And then in the end, you can create something like this, where you can here you can see like, okay, the first floor is 24% done. If you read 5 pages through the PDF document, that's pretty hard to see from there. So very simple analytics, just a couple calculations after a couple beers, and you can see the space group level, and then just some random numbers, just as an example there. And something that at the time didn't allow us to do today, during this weekend, was including the 3D model into this. So if you choose to see, okay, the comments for these specific spaces, you could dynamically choose the floor, and it shows it dynamically on the side. That would require us to integrate the GUIDs of the IFC models into the data set. Something to look forward in the future, possibly. That's pretty much it. The next steps will be to refine the user interface, of course, test it with the end users, the designers. If they say, okay, this is even worse than the PDF, then okay, well, then we need to change something and test with live data. And yeah, implement the 3D model into the data model for the Power BI as well. Yeah, I think that's pretty much it. Thank you very much.
Thank you for the presentation.
You.
Unfortunately, your team members disappeared, but I'm happy that you're here.
Yep.
Obviously, you have a quality instead of quantity. Or
Exactly. Yeah.
This is a very interesting thing to like how to make it more fluent, the work like among BIM designers. What was my question? Yeah. Why it hasn't been done yet?
Good question. Very good question. That's probably something you would have to ask Rico, who is not here today. But I believe one reason might be that there are different designer consultants from different companies with different software, and just something that hasn't been pushed from the top level down. Probably one of those reasons, which is common in the industry. There's no knowledge of the possibilities or the people like us who would do it.
Yeah. So basically, you started this work only this weekend, or did you have it piled up in your mind already before this weekend, or how much did you do it?
The problem was there, and we only used the IFC model that we had just to pull the couple test data from there, and everything else is just created here and could be up and running without the 3D model maybe next week, and with the 3D model in a couple of weeks. Depends. So it's very usable.
If I continue, if all the judges are still thinking, when this would be operable, then like when would this be in NCC use?
I mean, technically, theoretically, in a week or two, but of course you'd have to teach people and make sure that all the data is okay and good. But like from technical perspective, which is what I can answer to in like a week or two without the 3D models attached.
Maybe I didn't quite understand the final solution, but was it so that nowadays you are making manual notes about those changes?
Yes.
But with this system, is it something that automates that, or do you still need to
not
manual?
At this point, still manual.
Yeah.
And a very good question, because when we talked about this idea at work or this problem, and when we started thinking about the solution, and someone said, who was not a technical person said, hey, can we pull these like changes straight from the designing application? Possibly. I don't know how to do that, at least not yet. I'm actually still a student. I'm not that knowledgeable in this stuff, but I'm very eager to figure out and learn and ask other people. But yeah, I think that will certainly be possible from the designing software to pull the changes automatically and log those for sure.
Yeah, I think that is possible already. We also have on projects, we have these BIM coordinators who also do a little bit like this. Do you see a future where we don't need them?
Well, I've heard some rumors about these so-called BIM coordinators that you talk about. Never met them myself. I'm gonna plead the fifth, and
Well, I think they will have a role in the future as well, but that was just an idea that I have heard. That why do we need them?
I mean, the Astra can maybe do our jobs in the future as well. So the robot dog over here. So
Thank you for the presentation. I was just wondering that, so not knowing anything about the process, but is the data validated somehow? Like if someone says that, hey, yeah, we did this change, somebody has to check it, or is it okay if I just type it in and say that's all done?
yeah, well, something were thinking about was comparing the new version to the old version of the. If we have the data from the design software, okay, this is the new version compared to the last version. Okay, if you say that I have added a new stair to that staircase and move the door 5 meters to the right, and if you compare the new version to the old version, you can see, okay, has it actually happened? That will be some kind of idea, at least to verify, okay, changes have happened. And also then you can maybe see if changes have happened, but no one has reported on them, those. Or
Yeah. Okay, and the last question about the openness of the solution.
if you have the underlying data and the tools to do it, then sure, go ahead.
Yeah.
It's just an idea.
Okay.
Yeah.
Cool. Thank you.
Thank you.
Super. Way to hold it down for the rest of the team, man.
Thank you.
All right. So up next, we have our international teams. I came all the way from Estonia and Sweden. And anywhere else? Am I leaving out? I don't want to make sure I get everybody. No? We have 2 mics. 3 MCs and 1 DJ. All right. Estonia, Sweden, and then continuing their hack from Copenhagen, if I remember correctly. So
indeed,
super.
Hello, everyone. So we are a joint team of Cratamus and Wixforce, and we're going to present you an idea of a prefabricated wall panel configurator. So a little bit about us. We are from Cratamus. We build house configurators. We've been doing it for over the past 7 years. We're now iterating on the new generation of software called Modular Designer. It's a CPQ software, or configure price quote software. It's a simple designer for creating designs rapidly from modular components, pricing them and quoting them.
So Wixforce, we are a small company working with big projects. The projects are, yeah, let's go for the film. This is giving an idea for what we can do. And if we can visualizing it, we have a problem with the data. We can do modules. This is a very fast way of showing what we can do. But it's all come back to the design, production, and data is the gap. We do automation in factories all over the world, but we are facing the problem with data. We're analyzing it, the data is the problem. We are simulating it, the data is the problem. I hope you understand what the problem is. So Wixforce, we work a lot with data, and now we are making a bridge between design and production.
So just to reiterate, what is the problem? There's a gap between design and production.
Are we clear enough?
So we from Cratamus were on the design side, Wixforce on the production side. So together we tried to bridge it. So the problem really is designers need to have this production data at hand, right? During design time. Otherwise, you don't really know how much material quantities you need. And obviously, the production needs data from the design. Typically, designers provide data that the manufacturer cannot operate on. And yes, data is the bridge.
So buildings are made of many components. We are usually doing affordable buildings for multifamily houses. We have today selected to do a facade wall for all the buildings. So we have selected a building from Helsinki. We just took this photo and we took this photo from this building. It was 1936 outside our hotel. And we made the data or the dimensions of these facade walls and give it to Creatimus.
Live demo. So this is actually an online application. So on the left-hand side, you see a visual code. So it's a grasshopper-like interface, but online. So allows you to create definitions for the data. On the right-hand side, you see a very simple designer-friendly user interface to design with data. And on the bottom right corner, you see actually the outcome. So real manufacturable pieces that come out from a very simple piece of data. You can save, so you can manipulate it. You can drop different files in there. You can reuse the visual representations, but you can build your own representations as well. And you can save the file, you download it, and send it to production. So another file showed the save as well. So we got the JSON file down, and we sent that to production.
This is actually the wall that we are going to demo in the factory. So this is the wall from, you can continue. This is the wall that the 6-window wall outside my hotel. And we are very used to simulate our productions. And in this case, we took the data coming from Creatimus. So it's a data file there. We are downloading that into our model. That is a simulation model over the production. So the first thing we are doing is that we are actually using the data to produce the cutted pieces from a hamburger saw. We have a forklift that are transporting it to the framing station. There we have a semi-automatic framing station where a human is lifting the pieces, but all the other dimensions and so on is coming from the data created by Creatimus. This is what we do in other ways as well, but the new thing here is that to create data automatically almost. But this is the kind of traditional way of doing wall frames. And now we are creating a facade frame instead. So here's the 6 windows coming. They are made of a sub-element. So it's the same or right side size for the window. It goes out from the framing station to the sheeting station, buffer station first, and then we have a sheeting station. And the next frame is started to be produced over here. The robot is not moving now. We usually do that as well. So we're handling the material with the robots. But this is just for this demo. We are making the routing for the windows. It's of course nailing and gluing and things like that. And then the wall is magically flying to the building right beside our hotel. So there we have the first is insulated facade to that old building. And the next one is coming. We speed up a little bit, 30 times. And it's just visualizing the second wall coming up. And this is very, very, I mean, the tool here is very important. We can talk for hours. This is very important to analyze a production process. When we are talking about affordable housing, we need actually to do affordable things. we are not doing that in this industry. We are moving around with our manual screwdrivers and so on. But this is the way.
So the connection to production could give architects not only the knowledge about how materials it's using, but also how much time it could take. So could be a critical thing in actually design and construction planning. So, but otherwise, it's a tool for architects. It's a simple tool for them to use it to design, but also more computational designers, they can use it to create their own definitions for manufacturable walls. We asked several architects here, so thank you very much for giving us feedback. What is actually the problem? So how can you solve this problem? And many of you started giving us back the same solution, that do a definition, producible definition, and that's where we took the idea from.
Yeah, the solution is for manufacturers, and it will help them a lot to get the data running in the factories, but it's also, of course, for both parties. We are making the bridge. So the result of our collaboration is really that we have learned to work together. We have been talking earlier and we have seen each other, but we have never worked together. So we have established data and changed the format and are able to connect to each other. They are coming more from the design part and we are coming from the production part, and we're bridging that gap. That is a huge problem for us that are working on the production side of this industry.
So what next? So I think next step is really to find a producer that has done those wall panels and to really figure out all the technical details, because we know there's a lot more technical details than we realize behind it, but we believe that it's still doable. So in a way that we connect design directly with production. And yeah, what happens after that? I think everything would develop from that onwards. Thank you very much.
Yeah, thanks. Always interested in prefabrication and industrialization, as I talked yesterday about. So, so what was exactly what you did over this weekend for this production solution?
It's very much Creatomus part of it. It's our as well, but defining the type of data. I mean, that is from our side. There we are coming from or working with the production. It's super hard to get the right data. It's also a problem in a semi-automated factory and also in a manual actually. And the data format is varying all the time, and it's not really a standard. What we have established here, based on our background, we have been giving or agreeing about a format, and that means that we can use that data in our simulation, and the simulation is exactly as the factory itself in the future. That is a digital copy of that.
So is that format now proprietary to your company?
It's I mean, you have many different formats on the market. You have some standards, but they are not really strict. So we are building our format on a big factory implementation that we made both in US and in UK. But we have tweaked it as well because we need more data than normally is in this standard. But yeah.
So from our side, just to reply to the earlier question, is we actually developed a visual script that creates this wall panel. So we didn't have that. We had the framework set up before we came here. Just week before we came here, we started working on it. So, and we developed several software components that actually part of this visual script.
Okay.
And data format, I think I agree. That's the most important part, I think. We created here.
All right.
Yeah, I was just thinking about the impact you mentioned here, the time, but obviously there's going to be savings also in materials and money. So maybe join forces with the snitchers to get the good boy certificates also for your production. You mentioned a couple of countries there already. I was just wondering because as you know, the regulation is different in every country. So how are you going to adapt to that?
Yeah, the code is very different. We are working in Saudi Arabia, we are working in UK, we are working in the USA, and USA is a mess as well because the different states are different. We are very much into the California area, and that is very, very demanding. Yeah, you need to make your production for the design. I mean, you need to design for the production. And that means that the design is made for the Californian market. We need the production for that Californian market. And that is what we do. But the problem is that many times the producer of factories have no clue about what the designers and the architects are going to produce there. It's no standard. It's no really plan for what we are going to produce. So it's we are making factories all over the globe that are doing half of what they should do. All of them. We are making a new factory in UK now that is meant to do 32 boxes a day. I'm sure it will be half. It's Boklok in Sweden. They are doing this, but they cannot make the factory so it's produced in the right scale just because they don't know really what they are going to produce. So the answer is we need to adopt the design for the production. And when that is done, we have the code as well.
Thank you.
From the design side, sorry, this is why we use this visual scripting language. We can give the local architects ability to actually create their own scripts.
I was just about to ask you that. How do you do it? Like what? I understood that during this weekend that the visual script for the wood panel and the data format was the one that you made. So and then to scale up in the big time, you had to kind of work with the international actors and especially like a local architects so they can make it in a certain way. But it's not only one company thing. Are you able to share the solution somehow so the other companies, manufacturing companies, could take this model of work into use? So how do you scale up not only within your company but make it easier for others to take this into use too as well?
That's the whole idea. It's a platform. So you can create visual script not by country per architect, but for different manufacturers. And you can like almost connect to the same design, different scripts by different manufacturers and compare the data. Also potentially compare the material quantities and time it takes to produce.
So basically it's open source completely, or is it?
We don't know that yet. Again, if we are cooperating with a small or a big company, whatever, manual factory here in Finland or in Estonia or somewhere, or a fully automated somewhere, we just need to make the model for the production that are working together with the design. And then, as we already have established the format of the data, we will quite easily get that factory working because that is established. The problem on the market now is that you have machine suppliers, all kind of different machine suppliers that have different formats. So when a factory are going to produce, they need to handle all that different type of data, and it makes a big problem. The creation of the data itself is very difficult. I mean, normally it comes from a CAD drawing that someone is redoing, and it's thousands of hours for a multifamily house to spend. And if we can do that more automated and make data without CAD, that is what we see the future with data without CAD. And not for everything, but for what we are doing.
Lovely. We just took like, was it 20 years to get CAD into use? Now you're just dismantling it. That's okay. That's fine. We need to develop anyway. Do you want to have other questions? I'm cool as well. Thank you so much.
Thank you
for your presentation.
All right, super job. Always impressive, always impressive. So I will ask the judges to please meet in that room that's all the way down directly. Okay, actually go to the UrbanTech Hub. Okay, never mind. And then the rest of everyone else, enjoy, relax. We'll try to be back as quickly as possible with some results. And yeah, good job. flatulated the microphone. That was very embarrassing. Oh, okay, we're back. Oh, are we back? Are we back in streaming? Oh, we're live. Oh, shit. Oh, okay. Okay, so welcome back, everybody. We're getting ready to kick off. But first of all, let's give a round of applause for our judges, Kaisa, Arnie, and Toya, who had a very hard time. Judging. There were some moments in there that were pretty. There were some that were ugly. We can get the blood off the wall, but overall, it was pretty awesome. So again, a big thanks for the judges for coming out, their discussions, and then having to work this down. So I guess I'm in the way of the camera. So up next, we have click. Oh, this thing here. All right. So so we had these different categories. Funny enough, we kind of went with what you uploaded and then kind of moved some things around. So the best mashup project, no one went for that. So so that category is removed. So we actually have four different winners coming up. And so ultimately, I would hope that everyone solved their Monday through Friday problem. So in that case, hopefully everyone is a winner. That's what's kind of cool about this idea, is that you came, you worked on something, hopefully you continue to keep working on it. And so the next is the winners then, correct? The slides? All right. So, okay, doesn't reveal yet. Okay, here we are. You can tell who put the slides together, right? So, you know, it's very much teamwork makes the dream work. So, and the winners are, drum roll. So for the first category, best overall project goes to the Snitchers. All right. You guys, I mean, y'all can sit there and then we will distribute your prizes to other people. But we will ask somebody to grab a picture of the team. So if you don't mind, maybe Eska or someone, or Miriam. Okay, super. Yeah, come up on stage. Don't be shy.
Yeah, thank you. It was a first event, I guess, for all of us, and we really enjoyed it. We had a good time. We were able to come up with at least some solution for one problem in our industry, and yeah, thank you for everyone. And we found the poop.
Yeah, awesome. Great job. Super. Awesome. Thank you. And of course, don't forget, everybody gets a bucket. So, and please take them, because we have plenty. All right, and then so up next, of course, then drum roll. So for the next, we have solves a big problem. Piletastic 4, come on up. So, congratulations, gentlemen. Yeah, and.
Thank you. It's very nice here, and we hope that we can solve even bigger problems in the future. Thank you so much. Great event.
Super. Short and sweet. All right. Astro came to join y'all. Super. All right. And then we only have 2 more, so drum roll doesn't have to be too much longer. And best hack from past event, Curtimus and Wilkes for. All right. So this is another reason why you want to continue your hacks at other events. And so, as we mentioned, they also came all the way from Copenhagen in the last event. I mean, of course, they're coming from Estonia and Sweden, but they participated in that event as well. So it's so great to see y'all. And if you just want to.
Thank you.
All right. Great job. And of course, there is a certificate in there for everyone, even their youngest team members. So now we can say that we've had 2 13-year-olds that have participated and contributed to the AEC Hackathon. And even though their 13-year-old was much nicer to the team than the last 13-year-old. So, and then our next category goes to Bid Buddies, best hack for humans. So. Oh, y'all became unpopular really fast. You had like 9 people on your team. What's it?
No, thank you, everybody. Yeah, this was great. Nice event. Thank you.
All right. Sweet. Okay, so so those were the different things. Now, of course, the judges are nice enough to stick around. So if you have any questions, they definitely have some comments for, I think, probably all the teams. So if you want, just at least, one person from your team, especially if you want to go talk to them. If you don't, we understand. But they are going to stick around a little bit because they did have some good comments, really, for everyone. So do please take advantage of that. Of course, now that you're a part of the AEC Hackathon community, if you ever want to participate in these events again going forward, you do get a discount code. And then also, if you ever want to come and participate in events in other countries, just contact me and we will try to accommodate you as best as possible. So like in the past, we've had people come from like Denmark to the event in San Francisco, and then sponsorship permitting, we try to get like a big Airbnb and things like that. So again, this is all a completely grassroots organization and things like that. And so I just want to give a big round of applause, of course, to our sponsors, Sitowise, UrbanTech Helsinki, and then the other, because my memory is horrible, Sweco, yeah, who was not here at all, which I'll have to go hunt Ricardo down for that. So a big round of applause for our sponsors, please. Yeah. Or do we have a slide for that? We had a slide for that probably. Oh, okay. All right. So I'll go by the slides. Oh yeah. So real quick. So this is key because all of us are from industry. We're not event planners. So everything is a improvement by community input, right? So if there's something that you want to see, if there's an idea that you have, a challenge, really anything. I mean, that's why I said this is your event. I mean, everything from the logo to the challenges, the way we do things is always some kind of input from people in the community, right? So in that, if you have an idea for something or whatnot, now I am a big fan of if you have an idea, you become the captain of that ship. So so we'll do everything that we can to support what it is. So please don't hesitate to share with us any ideas that you have on how to make the event better for next time. Outside of that, do we have any immediate comments, ideas, or something on how to make it better? Oh, this is that great finish. No one says anything. All right, awesome. Okay, so I'm just going to assume everything was great. That's super. Of course, if you have any complaints, we do have a complaint department as well, but we normally don't get many of those. So, and then of course, before we say thank you and see you next year, just a huge round of applause for Vapu, Mariam, and Temu, who actually organized and did all of this. I just pretty much jet lag zombied in the corner. So a round of applause for these three, please. Come up on stage and speech.
Right.
Speech.
Thanks, guys. It's been really fun weekend, and of course, it's our pleasure to organize these kinds of events and co-creation for the better of the industry. And it's been a while actually since we've had these AEC hackathons in Finland and in Helsinki. I think last time was 2018.
Yeah.
So hopefully we can now organize this on an at least annual basis. So yeah, we don't know the date yet, but let's see you guys, all of you, next year. Any final words? No.
Yeah, I think like we actually maybe talked with some of you, it's not so much about companies, but it's the forerunners in those companies. And I think this ecosystem has proved it like right. So it's about you.
Mm-hmm.
Yeah, the change.
Awesome.
All right, thank you.
So then just in closing, don't forget, please do grab a bucket. Feel free to take one for a family member as well, right? That's very important. We definitely have plenty, and I don't know if it'll last till next year.
One more thing.
Yeah.
If people are wondering what's in those buckets that winning teams got.
Oh yeah. So tell us their prizes, Teemu, for winning.
So all the winning teams actually got tickets to the next WDB conference, so World of Digital Built Environment, coming in September.
Which is worth how much per ticket?
Oh, about 500 euros.
Woo!
So hope to see you all there, either in Tallinn or Helsinki or both. And we probably will have some hackathon session within the program as well. Then, of course, there was certificates and some bubbly for the whole team to share.
Yeah. And then, of course, for the winners, if you want a ticket for next year's event, that also is gratis as well. And then outside of that, yeah, I think pretty much the next event, if anyone is interested, is in Australia, right around the corner. And then Brazil, and then the closest one to here actually is going to be in Estonia. That's going to be in the fall. So if anyone would like to participate in that, that will be with the Ministry of, what is Jansar? It's like the Ministry of the Economic something and the Digital Construction Cluster. So I think it's more than Ministry of something and something, but they're
Ministry of Economic Development and Communications.
There we go. Okay, so so that's going to be a really good one, and so yeah, just keep us posted on what we're going to do. Again, from the bottom of my heart, thank you everyone for coming out and giving us your weekend. I know that's very difficult when the sun is shining, especially here in Finland, and winter ran a little bit later. So on that, of course, if you do continue your hacks, which we hope you do, I do appreciate that you open sourced a lot of this as well. As you continue to go through, if any of you do want to start looking at becoming a company or what do you need to do, we are finally at a point in the community to where now we have like VC mentors. So not necessarily, I think we're all a little bit too early to pitch, but if you're looking for good feedback or how can we, kind of go forward, we do have those mechanisms in place. So just feel free to reach out to us. And outside of that, if you're looking for people to kind of test or pilot your project as well, that can be arranged. So just kind of reach out to myself, or on LinkedIn, we have the AEC Hackathon community, or even in the Slack. Those three things. The Slack is a little bit quiet, so LinkedIn might be better. But we really want to encourage you to continue doing what you're doing. And so in that, thank you very much. And we have a little bit longer here, but for the most part, yeah, have a great time, and we'll see you next year. Well, I didn't do anything, but you're very welcome.
Thank you, Damon.
So cool. All right. And break. All right.